Live streaming is on.
Just like I said earlier, right? The most important thing you guys need to do most times when you're solving a problem is that you need to identify what kind of problem is that first. So is it an unsupervised problem or a supervised problem? When you now identify which of this problem it is, then you can then know which of the algorithms to use. You understand? So if it's a supervised problem, you can know that, oh, you might make use of decision tree, random forest, and all of those. All right, Miss M. So you can then know if it's decision tree, random forest you're going to be making use of, or just a simple linear regression to solve it. If it's an unsupervised problem, you know that you might want to use maybe logistic regression, support vector machine, naive bias, or k-means nearest neighbors rather, right? You might want to use all of those. And if you want to go further with your implementation, since you can try out different algorithms basically. So for example, maybe you have an unsupervised problem and you identify that it's an unsupervised problem. And you also know that that unsupervised problem has different kind of algorithms you can use. You can use decision tree, you can use random forest, right? Then you can implement that particular solution using decision tree and random forest. So when you use the two, you will then compare the two, right? I know you guys have done something like that on the Kaggle course.
Allah.
You might have done something like that on the Kaggle course, right? Where you needed to do a comparison, right?
Yes.
Which of the algorithm gives you a better score,
Yes.
right? So you can also do that just to extend your knowledge of this algorithm. So when you identify that a problem is a supervised learning problem, you look for all the algorithm that works with supervised learning problems. Then you implement that solution with those different algorithms one after the time, right? You do for decision tree, you do for random forest, you do for linear regression, and check all of them and see what the accuracy level is. There's this, I know you guys have worked with accuracy score, things like MAE, as the mean accurate, mean accurate score, or mean accurate, what is it again? Hmm, Keep my mind. While you guys were trying to calculate the score, there's this mean absolute error. Yes,
Oh
that's what I
yes.
call it. Mean absolute error, right? That mean absolute error is just the score, right? Just to know how well it performed, right? That will determine how well it performed. So if you try all of these different algorithms, you can calculate the mean absolute error of each of these algorithms. When you calculate them, you will now be able to compare that, oh, maybe decision tree performed better than random forest, or maybe random forest performed better than the simple linear regression, right? And all of those. So that's how you know that which of the algorithms works better. So in the future, maybe you are asked, maybe Rahim or Collins, and they tell you that, oh, perform a machine learning algorithm on this particular problem, right? If you see the nature of the problem, your intuition can already tell you that, oh, it's random forest that will give a more better accurate score to this problem. Or it's so and so algorithm that will give a better score to this algorithm, to this problem rather, right? If you go on Kaggle, right, and you type out maybe spam or harm, you see you can check people's notebook. There's what we call notebook section on Kaggle. On that notebook session, you see different people's solution on how they approach the problem. Right? Some people do a lot of advanced things which you might not necessarily need to bother your head on for now. But some people as well, you see the way some people used to implement these algorithms. They might even implement it with three different kind of algorithms and compare the scores. So you can just go on Kaggle for inspiration. Maybe you're trying to implement a particular algorithm. You can just go on Kaggle, search for the name of that problem, check for people's notebook and you will see the way they solve that solution basically. So I'm sure by from today you guys will be able to work on that. That's the fourth and fifth contact session. Where will now be able to take it up from there. But meanwhile, before then, you guys can always reach out to me. Then we can have who was having issues with Selenium the other time.
That was Oluwaseun.
Oh, okay, all right. I was trying to reach out to him so that we'll be able to together and see what the problem is. But nevertheless, this is not available. We'll get try and contact him. So aside that, were there any difficulties when moving forward? But yeah, about to say something right here before. No.
Oh no, I wasn't. I wasn't.
All right. Call and talk about it.
Oh, I'm good for now. When at least between now and weekend, as I attempt other tasks, if I get stuck anywhere, I will just reach out to you, just like you told us to reach out to you, if anything.
All right. Yeah, that will be fine actually. That will be fine. So Rahim, you don't have any.
No, same with Collins. I'll message you on Slack or I'll message Collins even if we need anything.
Okay. All right. So yeah, I think your test is supposed to be on Monday, right? So it's not actually far from what you guys have been learning, right? It's just make sure that you understand how you implement these algorithms, right? The different steps, right? You know, we have the processing step, we have the modeling step. Which other step do we have while we're trying to then you train your model and all of this? So just understand those steps properly. It's not far from what you've done before. Just it's just same thing.
Okay, so
Okay, okay, thank you.
All right. So yeah, before then, I hope we'd be able to be able to take any question before the Monday, right? Be able to. Uh, so yeah, I think for today we are good. All right. So hello, Mr. Ben. Can you hear us, Mr. So yeah, I think that we could be done with this conversation. Because, so yeah, we'll see before Monday. Also see after them for review, but just make sure you just lay down your questions before that Monday on Slack.
Okay.
No problem. So I see you guys on Monday. And do have a lovely day ahead.
You too.
Thank you.
All right. Thank you.
Yeah, you too.
Mohammed, is the class over?